All right, these are the answers to the extension worksheet. For the first one, we're giving a position of a particle from time 0 to time 7, times in seconds, and the position is in feet. So when is the particle moving to the left? When are we moving to the right? We'll answer that by finding the velocity and seeing when the velocity is positive or negative. So our velocity for this would be negative 4t plus 12. So then I want to know, when is that velocity 0? Because the only time I'm going to be able to change direction is if my velocity is 0, right? So negative 4t plus 12 equals 0 when t equals 3. So that's the possible change of time where we change direction. Put 3 in here. I'm going to test my velocity on either side of 3, see if it's positive or negative. So if I pick something less than 3, say I pick 0 and put it in, I'm going to get a positive. That means we were moving to the right before 3. If I pick something bigger than 3, say 5, put it in, I'm going to get a negative. That means I'm moving to the left. Since this was restricted between 0 and 7, we're moving to the right from 0 to 3, and we're moving to the left from 3 to 7, based on that parameter, okay? And again, right because velocity is positive, left because velocity was negative in those spots. Find the total distance traveled by the particle. So in order to answer that, I'm going to take the integral from 0 to 7 of the absolute value of velocity. So that way, any of the negative velocity is turned to positive. I don't care if I'm going left or right. I just want to know how far did I go altogether. So to do that, I do math 9 and get the integral. Then you slide over to that number and you pick the absolute value. That pops up on your integral there. And then you can type in your velocity, which was negative 4x plus 12. So again, we're putting in the velocity, not the position function. All right, and hit enter. And I'm going to get an answer of 50 feet. Okay. What does the following represent? Well, now we're integrating just the velocity from 0 to 7. So this would represent our displacement or change in position from t equals 0 to t equals 7. Okay. And then that answers that one. Then we switch over. Now we're looking at a different velocity equation. And we're told that if the position at 0 is 4, what does the position at 7 equal? So we're going to start with our initial position of 4 plus how did my position change from that time 0 to this time 7. And again, we just described that exact same thing right there. We said that this represents the displacement or the change in position. And now we want to use that to see how did our position change. So I take my calculator, go 4 plus math 9 from 0 to 7, and I type in that negative 3x squared plus 6x plus 24. All right, and it gives me negative 24. That's my new position, the position at 7 seconds. Okay. What is the total distance traveled? Well, we already did one like this, right? It's from 0 to 7. We're going to do the absolute value of velocity. And so if I go math 9, 0 to 7, of math, slide over absolute value, and then type in negative 3x squared plus 6x plus 24 dx. I'm going to get, it just takes a little bit of time, but eventually it gives me 188 feet. Okay. Number 2 here gives us the rate that cars enter an interstate starting at 6 a.m. And we'll call that time 0, is described by the function r of t, which is in terms of cars per hour. At 6 a.m. there are 550 cars on the interstate. So we want to write an integral that represents the number of cars that enter the interstate between 7:30. So we're not asking for the total number that are there. We just want to know how many came in from 7:30 to 9:15. So this is going to be the integral. 6 o'clock is time 0, so 7:30 would be 1.5, 1.5 hours later. 9:15 would be 3.25, 3.25 hours later. And the rate that those cars are coming onto the interstate is r of t dt. So this would give us how many cars entered the interstate between this time and that time. B says write an integral that represents the average rate from 6 to 9. So from 6 to 9, that's 3 hours. So we're going to take the number of cars that entered the interstate, we're going to divide by 3. That'll give us an average of cars per hour. How do we know how many cars entered the interstate? Well, we're going to go from time 0, that's 6 o'clock, to time 3, which is 9 o'clock. And we're going to integrate the rate. So if this integral right here represents how many cars entered the interstate from 0 to 3, spread that over 3 hours and we'll get our average rate cars per hour. And then C says if L of t represents the rate that they're leaving the interstate starting at 6 a.m., can we create an equation C of t that represents the total number of cars on the interstate anytime after 6 a.m.? Well, C of t would be how many cars did we start with, which we were told the beginning was 550, plus the number of cars that came on the interstate from time 0 to time t, right? So we're not given an ending time. We're saying we want this to kind of be continuing on. And so I need the rate that they're coming on, which is this r of t. Now, technically, this is not proper to have the same variable here as there is here. So it would be more proper to replace that with an x or something like that. If you put a t in there, you have the right idea. So don't get too panicked, but technically we don't want the same variable there. Okay, so this is the number of cars that will come on the interstate in that time, but then we have cars leaving the interstate from 0 to t at a rate of L of, and we'll call it x dx. Now you're welcome to combine that into one integral, make it the integral 0 to t of r of x minus L of x, or you can keep it separate if that helps you understand it. Now, we want to write an expression for C prime. Well, we have our formula here for C of t. So C prime would be the derivative of 550, which is 0. Then the derivative of this, the derivative of the integral, is just r of t, minus the derivative of this would just be L of t. And that makes sense. The rate that they enter minus the rate they leave would be the change in how many cars are on the interstate at that time.